Students, in the last class we have seen that whenever you are having a signal called as f of t, when you are multiplying with of del of t, what is the result we are going to have? Can you please recollect and tell me? In the last class we have discussed this. F of t multiplied by del of t. So what we can do? The impulse is present at t is equal to 0. So t is equal to 0 is put inside the f of t. You will be having f of 0 multiplied by del of t. So it will lead to the sample of the signal. Wherever you are having an impulse, the impulse is present at t is equal to 0. So we will be having a sample value of the signal, which is f of 0 multiplied by the of del of t. So it is f of 0 multiplied by del of t. Now, what if I want the convolution of it? I know the product, now I want the convolution. Or in the other way, f of n convolved with of del of n. Right? Using the formula of convolution, I can write it as summation. Please tell me the formula. It is equal to summation k is equal to minus infinity to infinity f of k del of n minus k. Yes or no? Summation k is equal to minus infinity to infinity f of k del of n minus k. Now can you please tell me, where do we have an impulse? Where do we have an impulse? Can you please tell me what is an independent variable inside the summation? Inside the summation, k is going to be the independent variable. If you remember, the first process of convolution, we have changed the independent variable from n to k. Second step is that h of k, we found out h of minus k, time reversal. Third step, we have done the shifting. So when you are doing the shifting, then this n will come into picture. So this n is nothing but the shifting parameter. The n that we are discussing here is nothing but the shifting parameter. So overall, inside this, k will be the independent variable. Inside the summation, k is going to be the independent variable. So if k is the independent variable, can you please tell me, we have an impulse at n equal to k or k equal to n? Do we have an impulse at n equal to k or k equal to n? Yes, very good. So we have an impulse. This is equal to 1 for the value of k is equal to n, and it is equal to 0 otherwise. So I'll be putting the value of k is equal to n here. I'll be putting k is equal to n here. Summation f of n multiplied by del of n minus k. F of n can come outside. Summation del of n minus k for the value of k ranging from minus infinity to infinity. Now what is the value of this? Summation of a unit impulse. Of course the unit impulse here is delayed, reversed, whatever it is. But doesn't matter, the area or the summation of it is always going to be equal to 1. So the result we are getting here is f of n. The result we are getting here is f of n. So what is the meaning of this? That whenever we are going to convolve a signal, any signal with it of an impulse, the result will be the signal itself. It's a very, very, very important result that we are having here. Extremely important result. F of n convolved with del of n is going to be equal to the of f of n itself. Very important. Okay, so I'll repeat once again. See, we have started here. We are curious to know, if you are convolving any signal with of the impulse, what is the result we are going to have? So what we are doing, we are expanding it first of all. We are expanding the convolution. So we are getting f of k multiplied by del of n minus k. Now what is del of n minus k? Del of n minus k is nothing but it is equal to 1 for the value of k is equal to n. Why we are writing it as k equal to n? Because inside the summation, k will be the independent variable. Inside the summation, k is going to be the independent variable. So at k is equal to n, we will be having the value of the impulse is equal to 1. So we are doing the same concept, whatever concept we have learned here, the same thing is going to be applied here. The same thing is going to be applied here. So del of n minus k at k is equal to n. At k is equal to n, we are having a impulse here. So we are putting the value of k is equal to n inside this f of k. So we'll be having f of n, right? So f of n multiplied by del of n minus k. F of n, here the summation is changing from k is equal to minus infinity infinity. It is not dependent on n. So this can be considered as constant. It can come outside as it is not changing with respect to that of k. So f of n multiplied by summation of all the samples of del of n minus k, we know that the area or the summation of all the samples of the unit impulse will be equal to that of 1. So the result is f of n. Okay, so f of n convolved with of del of n is equal to f of n. We can also write in the continuous time domain that f of t convolved with del of t will also be the same result, which is going to be equal to f of t. You know, the biggest confusion that the students have is the confusion between the multiplication and the convolution. Many students say that f of t multiplied by del of t is equal to f of t. F of t convolved with del of t is equal to f of 0. Okay, so let us not have that confusion, because what we are doing here, any signal when you are multiplying with del of t, what will result? It will result in a sample of that signal wherever you are having an impulse, because the impulse exists only at that instant where the impulse is occurring. In the remaining instants, nothing is there in the case of an impulse. So the signal also becomes 0 when you are multiplying f of t with of del of t. The signal also becomes 0 because of the multiplication at the remaining points where we don't have an impulse. So it becomes f of 0 multiplied by del of t. Rather, when you are trying to convolve with of del of t, then what happens is that the result is nothing but the signal itself. The result is nothing but the signal itself. So let us understand what is the meaning of this. If your input is x of t, the input is x of t, and the impulse response is h of t, and the h of t here in this case is del of t. Here in this case, let us consider it as del of t. Then what is the output? Then what is the output? The output y of t is going to be equal to x of t convolved with it of h of t, which is x of t convolved with it of del of t, which is equal to x of t itself from the current result we got. From the current result we got, this is what it means. Whenever you are having the impulse response as impulse itself, whenever your impulse response is nothing but impulse itself, what is the meaning of this? Impulse response is impulse. Impulse response is impulse means whenever you are applying the impulse as the input, the response is also the impulse. Whenever you are applying the impulse as the input, then the response is also impulse. Then what is the system doing here? What is the system doing here? If the input is an impulse, the output is also an impulse. The impulse response is an impulse. The impulse response is the impulse. Right? So it means that the system is not doing anything. It means that the system is not doing anything. It's a buffer. So therefore, if you are applying x of t, the output is also x of t. If your input is x of t, the output is also x of t. Right? So therefore, h of t is going to be equal to del of t. Time shifting property of convolution. Time shifting property of convolution. Time shifting property of convolution. So when we know that x of t convolved with h of t is y of t. When we know that x of t convolved with h of t is y of t, x of t minus t1 convolved with h of t minus t2 is equal to what? See, why are we using these properties? Because properties are going to make things simple for us. If you are not using properties, then you have to do the same process again and again. For example, if you already done the hard work and found out that the convolution between x of t and h of t is y of t. When we found out that the convolution of x of t and h of t is y of t. Now, you are having a signal which is a delayed input, x of t minus t1, h of t which is also delayed. Then is it required to once again do the convolution to get the result? Because we have already found out for x of t, h of t convolution it is y of t. Now when the signals are delayed, delay means nothing but a simple time shift. So when you are having a signal which is delayed and the impulse response which is delayed, is it again required to find out the result of convolution? The answer is no, because of the fact that we are having properties. So the properties will help you to quickly answer a question, right? So if you are having the delayed input and delayed impulse response, the output will be the summation of all the delays. The output will also be shifted, but the amount of shift will be equal to the sum of all delays. So amount of shift at the output, amount of shift at output is equal to sum of all shifts in input plus impulse response. Input and impulse response. So x of t minus 1 convolved with h of t plus 1. Can you please tell me the result, what it is going to be? X of t minus 1 convolved with h of t plus 1. What would be the result? Y of t, summation of all the shifts. Summation of all the shifts means minus 1 plus 1. Summation of all the shifts. So minus 1 plus 1 gets cancelled out, you will be having y of t only. X of t plus 4 convolved with h of t minus 2. It is y of t plus 4 minus 2. So it is going to be y of t plus 2. Input impulse response convolution, it results in output, right? So now you are applying the shifts in the input and the impulse response. The output is also going to be shifted. The output is also going to be shifted. How much shift in the output? That the shift of the shift in the output will be equal to sum of shifts of input and the impulse response. Sum of shifts of input and impulse response. So minus 1 plus 1, it is 0 here. Plus 4 minus 2, it is plus 2 here. So here x of t convolved with h of t. What is h of t? Del of t minus 2. We know the result that x of t convolved with del of t. X of t convolved with del of t is x of t. X of t convolved with del of t is x of t. But here you don't have del of t, you have del of t minus 2. So all the shifts are going to be added in the output. Okay. So here there is no shift. Here there is a shift of minus 2. So there will be x of t minus 2. X of t minus 2. So if your impulse response is the delayed input, then the output is also going to be delayed input. I'm sorry. If the impulse response is the delayed impulse, if the impulse response is the delayed impulse, then the output will be the delayed input. If the impulse response, so what is the meaning of this? That if you apply the input as del of t, if the response is del of t minus 2, this is what we are calling as h of t, right? This is what we are calling as h of t. So if you are applying del of t as an input, if the impulse response is the delayed input, then obviously if you are applying x of t here, you will be getting x of t minus 2. You will be getting x of t minus 2. So this is what we call as the delay circuit. This is what we are calling as the delay circuit. So whenever you want only delay, your impulse response should be something like del of t minus t naught. Okay, so whenever you want a delay, then what? X of t so your output y of t, if you want it to be equal to the delayed input, x of t converted with h of t is y of t. If you want your output to be equal to delayed input, if you want your output to be equal to delayed input, then your h of t should be what? H of t should be equal to del of t minus t naught. Then h of t should be equal to del of t minus t naught. So this will work like a delay circuit. This will work like a delay circuit. So whenever you want a delay system, your impulse response should be equal to del of t minus t naught. Your impulse response should be equal to del of t minus t naught. In the same way, here, see here I am representing my system with del of t plus 3. I am representing my system with del of t plus 3. The only thing that can represent a system is nothing but your impulse response. Okay, if you want to represent your system using something, that something will be the impulse response, right? So if you are having del of t plus 3 as an impulse response, if you are having del of t plus 3 as your impulse response, then the output will be x of t plus 3. Because what is the meaning of this? The meaning of impulse response given here is that if you apply del of t as an input, the response of the system is del of t plus 3. The response of the system is del of t plus 3. Then what is going to happen to your input? If you are applying x of t, you will be getting x of t plus 3. So advancing system, x of t convolved with h of t is equal to y of t. So if you want the signal to be advanced, whatever applying as an input, if it wants to be advanced, your h of t should be del of t plus t naught. So whenever your h of t is del of t plus t naught, your input will be advanced, or your output will be the advanced input. The output will be the advanced input. Similarly here also, is it applicable for discrete signals? Of course, yes. See, intentionally I am writing in terms of continuous here, because whether it is continuous, whether it is discrete, the meaning is not going to change. We should have in our mind, okay, the difference between continuous time and discrete time is just the representation of the signals. Okay, but whatever operations that you are performing, whether it is convolution or the representation, it is going to be one and the same. So I can confidently write that if x of n convolved with h of n is y of n, and the output is nothing but x of n minus n naught. If the output is x of n minus n naught, then I can see that the output is nothing but delayed input. The output is nothing but delayed input. Then I have to understand that what the system is doing here. The system's impulse response is going to be del of n minus n naught. The system's impulse response should be del of n minus n naught. Right? Please take the question on secondary screen. So to get the output y of n, I will be applying the convolution. So if I am convolving these two functions, del of n convolved with del of n is what? Del of n convolved with del of n del of n convolved with del of n. We know x of n convolved with del of n is x of n. So what if x of n is del of n? If x of n is del of n, then the output is also del of n, right? So del of n convolved with del of n is going to be del of n only. Right? So del of n convolved with del of n is del of n. First thing. Second thing is that del of n convolved with del of n minus 1. Del of n convolved with del of n minus 1. From the concept of delay, it's going to be del of n minus 1. There is a minus, plus multiplied by minus is going to be minus. And then these two. Del of n convolved with del of n minus 1. Del of n convolved with del of n minus 1. It is del of n minus 1. Plus into plus is plus only. And here you will be having del of n minus 1 convolved with del of n minus 1. Del of n minus 1 convolved with del of n minus 1. It will be del of n minus 2. Okay, if you know that del of n convolved with del of n, it's del of n. Del of n minus 1 convolved with del of n minus 1. Whatever result you had before, the same result you will be having. Only thing is that your shifts will be added. Your shifts will be added. It will become del of n minus 2. Okay, and plus multiplied by minus is going to be minus. So these two will be cancelled out. So the result y of n will be, the result y of n is going to be del of n minus del of n minus 2. The result y of n is going to be del of n minus del of n minus 2. This is one approach of solving the problem. Approach 1. Approach 2 is that, see, once I write my x of n in terms of impulses, if I write my input in terms of impulses, then is it not something which can be written as the sequence? Because wherever there is an impulse, there you are having a non-zero sample. Here you are having a non-zero sample at n equal to 0, whose value is 1. At n equal to 1, there is a non-zero sample, whose value is also 1. We can represent a signal in terms of impulses. So the impulse is nothing but the presence of a non-zero value in a signal. So non-zero value is present how much? 1 unit at n equal to 0. So n is equal to 0, indication is the arrow. At n equal to 1, there is a non-zero value of 1 here. So you are having 1. Similarly, I can also write h of n, which is given as del of n minus del of n minus 1. I can write it as 1 comma minus 1. There is a 1 here, so I am writing 1 here. There is a minus 1 here, minus 1 I am writing here. So x of n is 1 comma 1 and h of n is 1 comma minus 1. So the convolution of 1 1 1 minus 1 1 1 minus 1 minus 1. So therefore you will be having a 1 0 minus 1. So 1 0 minus 1. If you want to write it, the arrow will be here. Right? So if you want to write this particular function, so I can write it as 1 at n equal to 0, again at n equal to 2, there is a non-zero sample at n equal to 2, with the value equal to 1 here, with the value equal to minus 1 here. So y of n is equal to del of n minus del of n minus 2. Y of n is equal to del of n minus del of n minus 2. So the answer is option A, of course. That is what we got even in this particular case. So approach 2. See, in the approach 2, if you remember, in the last class we have discussed about representation of a signal in terms of shifted impulses, right? The representation of a signal in terms of shifted impulses. So what we have learned is that whenever you want to write a particular signal in terms of shifted impulses, whatever non-zero value is present in the signal, there we can consider there is an impulse, right? So for example here 1 comma 1 is there. So if there is a non-zero samples at n equal to 0 and n equal to 1, I can consider two impulses, one at n equal to 0 and the other at n equal to 1. So we represent del of n minus 1 represents the impulse at n equal to 1. Del of n represents impulse at n equal to 0, right? So therefore here here it is 1 and here also it is 1. Now how to get the magnitude of it? The coefficient of the impulse is nothing but the magnitude of it, right? So similarly we are writing in the opposite way, that whenever you are having del of n, we are writing 1 here, del of n minus 1, we are writing 1 here. Here it is del of n, we are writing 1, minus of del of n minus 1, we are writing it as minus 1. So once you are able to write the sequence wise representation of x of n and h of n, just we have to apply the tabular method. We will get the sample form of y of n. So once we get the sample form of y of n, you will now represent in terms of impulses, like n equal to 0, there is a sample, and n equal to 2, there is a sample. So what I am writing? Del of n minus 2, the value will come as a coefficient. The value is going to come as a coefficient. Next question is x of minus t convolved with del of minus t naught. Del of minus t naught. See, del of minus t naught, in yesterday's class we have learned one thing. So whenever you are having a representation like this, I can write it as del of minus taken as common, t plus t naught. Now I can bring this minus outside. This becomes 1 by mod of minus 1 del of t plus t naught. Now you see, your impulse response is nothing but del of t plus t naught. It means if you are giving input as del of t, the impulse response is nothing but del of t plus t naught. Correct? The impulse response is nothing but del of t plus t naught. So what is your system doing here? Can you please tell me? What is the system doing here? Very good. The system is doing the advancing operation, right? The system is doing the advancing operation. So when you are taking x of minus t as an input, if I do the advancing operation, this is what we are calling as an advancing operation, right? This is what we are calling as an advancing operation. So we will be getting x of minus t plus t naught. So in the place of t I am substituting t plus t naught. So it will be x of minus t naught. X of minus t naught. So the answer for this question is option D. This is the approach 1 of solving it. The approach 2 of solving it is that, let me consider, let minus t is equal to some k. Let minus t is equal to some k. Okay, so if I take minus t is equal to k, then I can write x of k convolved with del of k minus t naught. X of k convolved with del of k minus t naught. What we know? That x of k convolved with del of k. We know that x of k convolved with del of k is what? Is x of k. Then according to the time shifting property, I can write this is equal to x of k minus t naught. It is going to be x of k minus t naught, as we know x of k convolved with del of k is going to be x of k. Now you can substitute what is k? K is nothing but minus t. So x of minus t naught. Okay, so if the question is x of minus t convolved with del of t minus t naught, then what we have to do here? Then the operation we are performing here is nothing but t becomes t minus t naught, the delay circuit, right? So it is going to be x of minus t minus t naught. It becomes x of minus t plus t naught. Okay, so the last step of the approach 1, please look at the board. So what I can understand here is that del of minus t minus t naught is nothing but del of t plus t naught. I'm sure that this is clear, right? So now what is the meaning of h of t being del of t plus t naught? H of t is nothing but impulse response. It means if I give the impulse as an input, the response is nothing but the impulse response, which is del of t plus t naught. So clearly what your system is doing, the system is doing the advancing operation. So even if you are applying any input, so if you are applying the advancing operation, this is what we called as an advancing operation, yes or no? This is how we have learned as an advancing operation. See, we will not judge the advancing operation looking at what is present here. We will not judge about the advancing operation. I've always told you that we should not look at a shifting operation looking here. We should always look at what is happening in the operation. Okay, we understood that the system is doing the advancing here. So I've done the advancing operation here. T becomes t plus t naught, and I've substituted here x of minus of t plus t naught. It becomes x of minus t naught.